All right. Show that the angular deceleration of the system is 0.43 radians per second squared, right? So we're going to use torque is I alpha, right? The torque they're telling us is this, right? Whoops. So our torque is 0.010 meter newtons. Whoops. Okay. And then our moment of inertia is 4/3, m r squared, right? Okay, so our m is this. So plug that in for m. Plug this in for r, right? That'll give you the moment of inertia, right? Okay, plug that in for this. Plug this in for that. Do some division, and you'll end up with alpha. Yeah? Okay. And the number is between 0.04 and 0.05. I'll tell you that. Okay. Then it says calculate the number of revolutions. So now we've got this angular. Oh, there's the answer. It's the answer. Why, the answer's right there. Right. Okay. Calculate the number of revolutions made by the system before it comes to rest, right? So our initial velocity, we've got angle. Initial velocity, final velocity, alpha and t, right? The initial velocity is, what is our initial velocity? Oh, you got to figure it out, don't you? Right? Is v, oh, they tell us the v, yeah. Okay, so your initial velocity is going to be, you're going to use this thing, right? So initial velocity is, we're going to plug in 2.1 for that and 0.5 for that. Is it 0.5? Yeah, it's 0.5. So plug that in. This will give you your initial velocity. Boop. Our final velocity is, of course, 0. Our acceleration is what you got here, the 0.043. It's like 0.042857 or something like that. And the weird thing is that they'll use these rounded values in here. So don't feel bad about doing that, right? It, of course, is negative, right? And so the question is, what is the theta? Use no t, so use omega final squared is omega initial squared plus 2 alpha theta, right? Solve for theta. Theta will, of course, be in radians. So then divide by 2 pi, and that'll give you rotations. All right, good enough.